In today's video, I'm actually really excited. I'm going to do an introduction to OpenCV or computer vision. Okay, and we're going to learn some stuff. Some stuff I can't teach you because computer vision, like basic computer vision, is an entire semester's worth of material that you'd have to learn. You have to learn the background as to why you're doing what you're doing. We're going to spend more time in this video actually in Visual Studio. The majority of what I'm doing today, it's all going to be in Visual Studio. I'm not going to do anything really with PowerPoint except one extra slide. So what I'm hoping actually is, in the end, is to produce this lane finding application that you can use. And I'm gonna give you a video. You can upload the video, put it into your solution folder, and then we're going to use that to detect the lines on a roadway. Okay. And I'm going to also show you what happens when things go wrong, or what some of the limitations of computer vision can be. Okay, so let's hop over to Visual Studio, and before we do that, we actually have to download and configure OpenCV in our Visual Studio, and we got to create a template to do that so that we can come back and do this without ever having to reconfigure our computers each time we want to do an OpenCV project. So let's get into the download. So to get OpenCV, what we need to do is go to opencv.org. And right now I'm in the About page. So I'm opencv.org/about. Okay, so go to About. And if you have time, go through this and read and find out what OpenCV is really about. Okay, and have a look around on their website, and you'll see a lot of really interesting stuff. They have courses here. Their website talks a lot about that, the training that you can do, partnerships, bundles, pricing, all that kind of stuff. But for right now, what I'm going to do is I'm going to go back and I'm going to go to releases. And I'm going to go to OpenCV 4.4.0 at the time of this recording. And I'm going to download the Windows. And it brings me to this SourceForge page. And right away you'll see here it says your download will start shortly. Okay, and just give it a minute. Don't do anything. And then you can see it's downloading at the bottom of my screen. So I'm just going to hit the run. And it looks like it's about 203 megabytes. So it depends on the security you have on your screen, but Windows protected your PC. I'm going to run anyway this OpenCV. This is it's an exe file, and it is an extractor program that will extract some zip files for you. Okay, so I'm going to run anyway. And then I'm going to look for where I want to put it. So in my case, just for now, I'm going to put it, I think, on my desktop. What I will do is create a new OpenCV folder. Okay, rename that. Okay, it's being difficult. I'm going to put it in my new folder. Okay, right here. And let it do the extraction. So it's downloaded, and what I'm going to do is just change the name of that folder, and I'm going to call it OpenCV because I want it to be very easy for me to find when I come back. So what I'm going to do is I'm going to go to just click on that file after I've given it a new name. Down the bottom, I'm going to type in advanced, view advanced system settings. That's what you want, advanced system settings. Okay. Then here where it says environment variables, we need to set those up. So click on that. So when you're in the system variables, you want to scroll down to where you get to path. Okay. So we're going to go to path, and we're going to select edit. And in here, we're going to add the path to the OpenCV bin. So leave that there. And I want you to go back to your folder and go to your OpenCV, open that up. Okay, go to build, and don't go to bin yet. We're going to go to 64, click on that, and it's going to be VC15. Okay, now this bin, double click on your bin, and it's this path that we want here. So grab that that URL basically at the top of your screen and do a Control-C to grab that. Okay, and then we're going to go back to the advanced settings in here, and we're going to do a new, okay, because we're just editing and adding this environment variable. So new, and then paste that in there. So select OK and OK and OK. All right. So the next step is to go ahead and open up Visual Studio. So what I'm going to do with mine is I'm going to do a create a new project, and it's going to just be a C++ empty project, because what I want to do is, in the end, I want to actually create a template. Okay, so that I can open up every time I want to do an OpenCV project. I can just open up that. So if you notice, all of these are just project templates. Okay, so I'm trying to create my own for OpenCV projects. So I'm going to do an empty project, go to next, and I'm going to call mine OpenCV project template. Okay, and I'm going to save that to my desktop in my OpenCV. That's where I'm going to just save that. Okay, and yep, place solution project in the same. Yeah, that's what I'm going to do. Create. So I'm going to go to my source file, and I'm going to do an add new item. Okay, and this one is going to be a CPP, and I'm just going to call it main. Okay, there. So one thing that we really need to do first is change this. This in your Visual Studio will say x86. Remember, we did the 64, so make sure that that is changed to 64. That's a pretty important step. And then the other thing is, I want you to go to your template over here, okay, and right click on there and go to properties. We have to actually do some more setup, some configuration. So I'm going to go into C++ General, okay, and I need to do additional include directories. Okay, so I have to go back to my OpenCV project directory. So I'm in my OpenCV that I downloaded, build, include, okay, in this path, we want this path, okay. And then back here, and I will paste it right in here. Okay, and I will click, will it give me the apply? Yep, apply. So we're not done yet. We've done the C++ general. Now we need to put the linker in there. So this is where I want to go to additional library directories. So back to our OpenCV file. So I'm back to build, x64. We've got VC15 and library. I'm going to take this path, okay, back in here, and I'm going to paste it in my additional library directories. Okay, apply. And one more thing, I have to update this configuration here. I'm going to have it to debug. I know it was all configurations, but got to be debug. Okay, and then while it's in debug, make sure debug, and that's in there, and then okay. Okay, still not done. Got to go back in there, back to properties. back to linker, and now this input. Okay, we have to do the input because I've got some additional dependencies. So open that up and we're going to do edit, okay, and then go back into our where we had that library link. And so we already had that link opened up. It's the 6415 lib, and we want this one OpenCV _world 440D. Okay, and D stands for debugger. So we're going to copy that. Okay, go back to Visual Studio, and in this additional dependencies, we can paste that in there. Okay, so we're there. We're going to just hit OK, apply, and OK. Okay, so what I need you to do now is to go back to your project file, okay, your OpenCV project template, and I need you to grab an image. So in my case, what I've done is I have this image. It's just a screenshot from the last video, and it's a PNG. But you can use other file extensions. But for now, try to stick with a PNG in capital letters. So just go to the internet, download an image. Okay, so go to your project and open it up, and then paste an image into your file. Okay. So we go back to Visual Studio, and we have to do an include. Okay, and that's going to be, this will be different than you're maybe accustomed to, but OpenCV2, you can see the IntelliSense is picking it up. OpenCV2, and it's given me a slash, so I'm going to say OpenCV and accept the .hpp. Okay, accept that, and then we're going to do pound include. We're going to just do an IO stream. Okay, and then we're going to do a using namespace std. Oh, and we're also going to use a using namespace. We're going to call this CV, okay, stands for computer vision. Put that in there as well, okay, because I don't want to get the scope resolution operator and all that kind of stuff involved every time I need to call something from the CV library. So we're going to do int main. Oh, it's one of those mornings. Int main. Okay, and what we need to do is we're just follow along because we're going to explain everything. But mat img equals im read. Okay, and we're going to read that image. So I think mine was called I can't remember what mine was called. So I'm going to go and just copy and paste the name of what my image was. So this, what I'm saying is go and read the image that I had. Okay, get it into the system somehow. So now I'm going to call this a new or name window. Okay, and this will be image. Okay, so this is going to be a pop-up window that shows up on the screen, and it'll be window normal. See if window normal. So it's going to create a pop-up window when I compile this, and so the name of the window is going to be image, and I'm calling a normal window. And then I'm going to do im show. Okay, so it's going to display it, but you got to tell it what to display. So we're going to do display the image window, and then img. So that's, you're going to display the actual window and what's inside the window. Okay, and then finally we're going to do a wait key and give it a time of 0 so that it doesn't just shut off as soon as it flashes. Okay, and then return 0. Okay, and I'm going to now build my solution. Okay, it looks like it built just fine. 1 succeeded, 0 failed, and I'm going to start without debugging, and you can see here it opened up. So that's my little window, that's my image, it came to the screen. So all this to say, the reason I've done this is to create a template, because of all of that configuration that we had to do. I don't want to have to do that configuration again every single time I want to do an OpenCV project. So now what I'm going to do is convert this into a template file. Okay, so I'm going to shut that down. I'm going to go to project, okay, and I'm going to say export template. Okay, and I'm going to accept the first one, project template. A project template will allow a user to create a new project based on your exported project. A user will be able to utilize your template from the new project dialog box for client projects, blah, blah, blah. Okay, so I'm going to call it my OpenCV project template. Okay, and just keep all this stuff here. If I wanted, I could put an icon on there if I really wanted to, but I don't. And I'm going to keep it in, I'm going to keep it all in here. And notice at the bottom, it's actually a zip file. Okay, it is a zip file. So what I'm going to do is just click finish. Okay, and then I will just close that down, and I'm going to ignore where it is right now. Okay. So now I'm gonna close my Visual Studio, and I'm gonna open up Visual Studio again. What I want to do is learn a little bit about OpenCV, or Open Computer Vision. So it's an open source library that you can use for doing computer vision projects, such as rendering video to have your software detect the lanes. The lanes on the road, or traffic lights, or different objects, traffic signs. So what I want to do is go through this today, and what I suggest you do is follow along, do it step by step as I'm doing it, because for those of you that are in my class, this is what this week's lab is going to be, just running and doing this video. Okay, so follow along and do the best you can, because that's what you need to do for this week's lab. Okay, really quickly, what I want to do is just demonstrate, we've got these sliders. They will also have an impact on what your video is doing. So what I want to do is start a brand new project, but because we had already installed OpenCV, and then we created it as a template, what I want to do is say create a new project. And then up here, I want to just start typing open. Okay, and you're going to see that the template actually opened up. Okay, I've already got it listed on my console here, but I want for you, because it's the first time you're doing it, just select the OpenCV project template. And we're going to call this one lane finder underscore main. Okay, and I think for the purpose of this video today, it's going to be one project file. There's not going to be any header files or anything like that. We are going to draw extensively on other included files from the OpenCV library, but for now, let's just stick there. So if I go to where I want to save this, and in this case, it's going to be I think week 10 OpenCV, that's what I'm going to save it in. Place solution and project in the same directory, and I'm going to create that. Okay. Now, the one thing I'm going to say to you is that this can be computationally intensive for your computers. And so expect that when you do go forward and compile your code or build and run, there's going to be a significant lag. Okay. So don't also be surprised if when you're running your video footage that it's kind of slow. Okay, so that's kind of normal in this case. There's things you can do to speed that up. But in the meantime, just stick with the video, and we'll get there. And by no means are you going to be an OpenCV or computer vision expert at all at the end of this video. This is just an introduction of what OpenCV is, and it also builds on some things that we've done in the last couple of weeks. Okay, so we're gonna at one point do a vector in here too. So what I want to do is go over to my lane finder project file and go down to open folder in file explorer, because there's one more thing that we need. Okay, so we're in here, and what I need to do is go to my week 10, and I'm going to give you guys this road lane. If you don't have access, if you're on YouTube or whatever it is and you're not seeing this, then just go get a video of a car driving on a lane. Now, I'm also doing I'm a student in the Udacity self-driving car course, and they give a bunch of examples of roadways, but I think they're all over YouTube as well. So just find a way to download a video of a road. So I'll show you what this one looks like. Where's my open with? Oh, open with Windows Media Player. Okay, so that's what this one is. Okay, that's all that this this file is. Mine will be much more compact than this, but that's the video file. So what you're going to need to do is copy this and then put it into your lane finder project. Okay, so copy and paste it into there because it needs to be part of your solution file. Okay, because we are going to reference that and it needs to be able to see it. Okay, so the first thing I do want to do is I'm going to put this typical this line in here, but I have to open up my main. Okay, I'll open this up, and you're seeing that we had all this stuff from our template. Okay, so if I were to go and try to run this, it's not going to run because I don't have this file inside my solution folder, so it's not going to run that. Okay, so one thing I need to be very clear about is you're seeing all these errors and you're thinking, well, why am I getting that error from a template? And it's this here. It's this solution platform. We need to be in x64. Okay, so when you're doing this, make sure you're in x64. Okay, so all the rest of that stuff remains. We're not getting an error because I haven't run this. So I have a couple of things that I need to update, and I'm going to put this line in here right at the very top. Oops. I'm going to put that in there. Okay, and I have a couple of these HPP files that I need to put in because I do want to add a little bit of a GUI detail to this. Okay, so the first one is going to be it's pound include, and it's going to be OpenCV. I'm just waiting for my IntelliSense to pop in, but it's not doing it. OpenCV2 / and it's hi GUI. Okay, /hi GUI .hpp. Okay, there's that one there, and I'm gonna the next one is pretty similar, so I'll copy paste that. Okay, and that one is it's actually not hi GUI, it's IMGPROC, so image processor. So copy that and that. Okay, so I'm adding those in, and I've got my IO stream. Okay, so we're off to a good start, I think. Now, like I said, you're not going to become experts in OpenCV, okay? But I want to give you some good intro to it. So you noticed in my video I had a couple of windows that opened up, okay? And I'm going to put my window names in here, and I'm going to go with a const string, and I'm going to call it window name, and it's going to equal original. Okay, and I'm going to do another one. I'm going to do a couple of these. Okay, so let me just copy and paste that. Okay, and I'm going to call this window name 1 2, and 3. I'm going to change this one to HSV image. This one I will change to threshold image. And the last one I'm going to call is fine tuning. But I'm actually going to change this, not window 3. I'm going to call this one actually adjustment window. Okay. All right, so I've got those in there, and these are going to be, I'm going to be able to call these windows that I want to populate on my screen soon enough, okay? Okay, so I do have a bunch of functions that I need to put in here, and because I'm doing this all under one file, just as the main CPP, I'm going to write all of my functions above main, okay? Because as you know in C++, if you write them above, you don't have to prototype them at the top and then write the functions at the bottom. So I'm going to do all my functions above main, okay? And I'll put this note here, functions. So create a window for fine tuning. And before I do that, I need to do this void on tracking or track bar. Okay, one is an int and the other is a void pointer. Okay, don't worry about it for now, but you know, it's a function call. So we put this in here, and I'm gonna put in a note. Function called when track bar position gets moved. Okay, so that's when I slide my sliders left and right, it'll change some of my values that we're about to get into. Okay, so the next thing I want to do is I want to do these. There's a lot of stuff that you guys don't know about, okay? Computer vision is a monstrous area of artificial intelligence that you are likely not familiar with. But so I'm gonna have to just kind of give you the answer sometimes and not explain the full background, because it's an entire course all on its own just to do beginner computer vision. But what I'm gonna do is I'm gonna give you the values inside this function, and you'll see how we use them later on, okay? So this one I'm going to call a void set road, okay? And this one has a pretty long parameter list, okay? So this is going to be int min hue is going to equal 70. Okay, so I'm going to give you all the values, right? And then it's going to be int max hue is going to equal 179. Okay, and there's a lot of science behind these hue values. So we're talking about things that have to do with color. Okay, hue values within color, and this will be int minimum saturation is going to be equal to 0. Okay, and int max saturation is going to be equal to the value 87. Okay, and we're going to do int min value is going to be 0. Okay, and then I've got int max value will be equal to, I think, probably 77. Okay, I'll set that to 77. Okay, and we got a couple more of these. Okay, and we're going to do int min min canny is going to equal 50, and then int max canny will equal 150. Okay, and that's the end of the list. And I've got some errors because I can't type very well. Okay, and then I just need to close this out. Okay, and my computer is as slow as molasses today. Okay, so let's put in our brackets in there, and now what we're gonna do is we're gonna go and set all these. Okay, so what I think the best way for your sanity, instead of watching me type, is I'm actually gonna copy and paste them all in to where they are. Okay, and give it a second. Okay, so the reason you're seeing these errors here is because up above, right in the beginning, I have to sort of create this, these initialized values. Okay, and these are for my, right at the top. Where do I want to put these? Right under my namespaces. Okay, and let me put the note in there. So initialize min and max HSV, so that's hue, saturation, and value filter values. Okay, and then these will be changed using the track bars. Okay, so what I'm going to do is also, I will give you those in here. Okay, and what you should probably do is take a minute and pause the video. Okay, pause right here. Make sure you have those values, and then come back to here. And what it looks like to me is I've probably made some spelling mistakes all along the way. That's no surprise to anyone here watching this. So for example, max, where else did I do it? And min sat, right here. Okay. So it's important, obviously, to get your spelling in order. And max C, max can, okay, everything cleared off. So these values are initialized at the beginning, and then we're going to use this set road function to modify them. Okay, and I guess I'll just tighten that up. Okay, so I'm going to go ahead and save that right now. So there's one more thing that I need to put in right under the windows, the window names, is this Boolean. Okay, and the reason I'm doing this is because when I test these things out, I have a bunch of different videos, and I want to make sure that I'm kind of testing out the right thing. So I'm putting in this road equals true, because as I get down here in my create track bars, so right underneath our set road, I'm going to do this new function, and it's going to be called void, and I'll call it create track bars. I like to camel case all my spelling when I can actually spell. Create with a capital T. Okay, so create track bars, and it's going to be a function. Okay, and the first thing I'm going to say is if road, which we just put that Boolean above, equals true, then what I want to do is I'm going to set the call that set road function. Okay, so set road, is it in here? I don't, there it is, set road. Okay, and close that off. Okay, and right below that, then I'm going to do the named window. So my named window is going to be adjustment. Does it show up on there? Okay, there it is. So my adjustment window. So the next thing that I need to do is I'm going to put in a couple of notes here. Okay, and the first one will be that I need to actually create some little bit of memory for me, so that's going to be a character array. Okay, and I'm going to call this one, this will be a char track bar name, it'll be 50. Okay, and then the next thing I want to do, and I've got these, this comment I'll put in here, and this part I don't expect will make too much sense to you other than to say that I'm trying to put the actual track bar sliders in right now. Okay, so this creates track bars to insert into the window, and this window that we're going to open up is called adjustment window. So we're making this tool that will slide open and closed. So I think it's better just to show it to you. We're making these sliders here. Okay, so as you see, as I slide them, the image is changing. I've got that horizontal line. Things are kind of getting all distorted. Okay, you notice I can do that just by changing these values. Okay, so we're working on this, making these sliders right now, and then they're going to actually be implemented in the video after compilation itself. Okay, so that's what we're talking about. And when we look at this min H, max H, min S, max S, V, and V, okay, what I'm doing is I'm manipulating the hue saturation values in the actual video. Okay, and of course C is something else. It has to do with canny edge detection and things like that. But I'm gonna add that in there, and I'll explain that when I get to the canny part. Okay, so that's what we're working on right now. So I could type all of this in front of you, okay, but then you would pull your hair out completely. So what I've done is I'm just copying and pasting it in here. Okay, so the same values as before. So this is our track bar name. Okay, so we've got the titles min H, max H, and then we're referencing these values above. Okay, so that's what we're trying to accomplish with this here. And then while we're in there making the track bars, it only makes sense that we do the ones for the canny as well. Okay, and I haven't really talked about canny, but we will. So take a moment, pause the video, and type all this stuff out. It's not as simple as that. We've got some more things to do. So I've got 3 parameters to address variables that change when the tracking is changed. There's the min, the max values, and so we're going to put those in there. And so this function is what's called when we actually slide the bars across. Okay, so give yourself some space, and I'm going to just drop those in. Okay, and we'll look at those 3 parameters. Okay, this is the title, that's what we're referencing. This is the window, okay? And then you've got your, don't forget the ampersand, this reference to it, okay? So it's an ampersand min H and then max H, okay? So it's min and max because we're making the slider, which is the minimum and the maximum. And it's gonna be on the actual track bar, okay? So we'll do that for all 6 of the HSV, okay? And as you guessed it, we still have to do it for canny, okay? So we've got to do it for this as well, okay? So rather than me typing, we'll put that in, okay? So minimum C in the adjustment window again, and then minimum C, maximum C, and then on the track bar. Okay, now we are done for that function. Okay, so we're going to go into main now, and from here on in, everything else is going to be covered inside of main. Okay, now the first thing we do is we have to go and get that video. Okay, so the video that you imported into your project or you copy pasted into your project. So we got to do video capture. You can see it here. It's part of the OpenCV library. Okay, and we're going to call this capture. Okay, and it's a function call, and the actual name of it, the video that we had in our file, and let's go confirm that. And I want to do it this way. I want to go into my folder, because it's vital that you properly name this file. Okay, so it's called road lane. Okay, double click it with a little bit of a pause, copy that, so you've got the guaranteed spelling of it. Okay, and just add .mp4. Okay, that's all we need to add on there. Okay, so .mp4, because we're going to go in. This is how we are assigning the video value into capture. Okay, so we're creating the capture object, which is actually just, we're assigning the video file to it. Okay, so now let's just let's get down here. I want to do this if statement. Okay, so it's going to be if our capture is, if we're not in capture, let's see if IntelliSense catches it. Yeah, there it is. Not capture is open. Okay, and that's a function call. Then I want to put out an error. Okay, so I'm going to put cout error. Okay, so we'll put that in there, and then we're going to return a -1. Okay. All right. So that's the first thing we're going to do. Okay, and then we're going to get outside of that if. So right after this, I think what I'm going to do is call the create track bars function. So it calls it and creates the track bar slider box. Okay, so let's not confuse that with this function, the create track bar. This is the entire function that I'm calling. So create track bars with the camel case and the S. Okay, and I do apologize. I probably should have named that a little better. So what we're going to do next is you don't know what mats are at this point. You may, depending on some other C++ stuff that you've done, but I guess one way that I guess I could explain this to you is just consider it to be like a slide or a layer. Okay, so it's just kind of a layer in front or over top of something else. Okay, so right now we're going to call this mat. I've got a couple of these that I want to do. So I want a threshold, okay, and I want cap image. Okay, and that's capture image. Okay, I'll do a capture image, and I want an HSV img image. Okay, and then this DST. Don't worry about that. You just know that I want this DST. It'll come in handy after. Okay, so now I've got a while loop that I want to do. Okay, and let's do this. So while, okay, 1. Okay. Okay, so what I want to do is I want to get the, step 1 is to get the image or the video or the camera feed. Okay, so I've got options, right? I can get from my webcam or another peripheral camera device. I can take video, which is what we're doing in this case, or as you saw in the beginning when we did the when we built the template, we used an image. Okay, so at some point I have to get something to do image processing on. Okay, so what I'm going to do here is I'm going to take the capture. Okay, so technically what I'm actually taking is the video. Okay, so we put the video, this road lane video, into capture, and I'm going to put it into this mat, this cap image. Let's see, is it okay? So I'm going to put it into the image cap mat. Okay, and I think what I will do now is, my image on my screen is a little bit large, so I think what I'm going to do is I'm going to resize that down a little bit. Okay, And the way I want to do that is I want to do resize. Okay, it's just a function call, resize, and it's going to be, let's see, I'll go cap. These are just, you know, this is a function call, and I'm just putting in the parameter list. Okay, so cap image again. Okay, and then size, my size is going to be, I'm going to start off with 500 by 640. Okay, and so what it does, it's actually taking my original video image. You saw when I showed it, it was much larger. Now I'm going to condense the image file down a little bit. We can come back later and mess around with that. Okay. Now, the next step that we have to get into is a very, very important step. Okay. And I guess the best way to explain this is, let's open up the video. Okay. And let's see. I want to look at the video, and I'll show you what we need to do right now. Okay. So I've decided I'm just going to open up the video, okay? And you notice the size of the video is just absolutely humongous, okay? So that's why I've created it. I've shrunk it down to 500 by 640, okay? Now there's something I'm going to do. I'm actually going to transfer this image over to PowerPoint because I need to show you why. I need to show you something that's really important. So I'm going to take this, screenshot it, and put it into PowerPoint, and then we'll talk about it again. So here we are, we've got this image of the road, okay? And what I'm going to do is get my laser pen, okay? And we've got a horizon, okay? We've got this mountain range and everything at the back, okay? And we've got the actual end of the road, okay? But what do we really honestly need to focus on as a driver? Okay, is it really the whole entire road? Or do our eyes only focus on a very small part of the road? Okay, so when I look at this and I create this box, okay, this is where I know that I need to pay attention. This is where I need to do all my image processing. I don't actually need to process the mountain range or those trees or even that far off into the distance. I'm only interested in what my computer vision system needs to see with enough time to react. Okay, so what we're going to do is actually go in and code and make this box. Okay, this you can call it a mat if you want to, but it's going to be a box or a mat. The proper term in this case is going to be called a mat, and the mat is going to be called ROI, so region of interest. Okay, so when I say ROI, I don't mean return on investment, I mean region of interest. Okay, so let's go back to Visual Studio and look at that. So ultimately what I want to do is I want to be able to run the video and put this mask over top of the video to block out areas that I'm not interested in, and I just want to process the area of interest. So what we do is we actually define X and Y coordinates, and then we have B and C. Okay, so if our X and Y are 100 and 295, then what happens is we take 100 plus another 220, and then 295 plus another 185. Okay, so what this is going to look like, and it's going to be a rectangle. Okay, and I'll make it a const, and I'm just going to call it box. Okay, and it's going to be 100, comma, 295, comma, 320, comma, and finally 185. Okay, and close that off. Okay, so the next thing I'm going to do is, this is now, I've got the box, I'm going to put it into a mat. Okay, So it's going to be mat ROI is going to equal my cap, and you can see here cap image, okay, and it's going to be a box right there. So let's just put a comment there. This is my region of interest. Region of interest. Okay, now let's go ahead and save that. And we've got to do another step. Now, a lot of the stuff I do in this next step, not going to make any sense to you at all. There's an entire entire academic lectures on understanding what the rest of this stuff does. But what's important is that you're just kind of following along. You're seeing how I'm doing the function calls, and then later on, maybe you'll learn a little bit more about this, I'm hoping. And I'm going to put this little note in here as well. Okay, so we've got step 1, step 2, and step 3 is going to be something we call canny. It's edge detection. Okay, and I think explaining this truthfully is outside of the scope of this tutorial, but just follow along and understand that I'm doing a bunch of C++ function calls from the OpenCV library. So if you see right away it's got Gaussian blur, that's what I'm looking for. Okay, and I have a whole bunch of parameters that I need to put into this library function called Gaussian blur. Okay, and the first one is going to be ROI. Okay, that's our ROI. Okay, and then comma this DST, and we'll define the DST a little bit later on as well. Okay, and now size. This, it would be an entire lecture to try to explain my size, but just suffice it to say for now, you need it to proceed with this this tutorial. 1.5 and 1.5. Okay, and I'm going to close off that function. Okay, so there's a couple other things we still need to do. Okay, and these are called morphology exe, and if you want, you can get in and read about what's going on in this particular function. But you see that it is an OpenCV function. Okay, and we have to pass in all these different values in there. So it performs advanced morphological transformations, and you can go through, please, and read this or hit the search online if you want to know more about what this does. Okay, and I actually missed a step, so I need to go above this one. I'll come back to this one in a second. Okay, that's the wrong parameter list, but I missed a step. I need to do another, I have to make another mat, okay? And the reason I need the mat is so that I can put it into this morphology X, okay? And this is going to be, I'll put a note in here too. So, okay. And what I need to do is do a mat, and I'm going to just call it K. So it's going to be mat K, and I've got this get, let's see if it's in there, structuring element. Okay, I need this. Okay, and that is also a function, and inside that function, it's going to be called morph. Okay, so I've got all these different objects, and I'm looking for my morph rectangle. There it is. Okay, so that's morph rect and size. Okay, 3,3. And there should be a second closing bracket there. Okay, so now that I have the mat, now I can go and complete this one here. So this parameter list is ROI, ROI, and this will be morph, close. So that's morph, close, and then finally we'll go get the K mat. Okay, so that's done. Okay, so what else do we have to do? I've got to get this final function here, okay? This canny, and I mentioned the canny previously, but now I need to go and get it. And this is where we've got our min C and max C. Okay, so those values that we put in the tracker, that's these two min and max for our canny. Okay, and that has something to do with detecting edges. So what this canny does is it has to do with detecting the edge. Okay, so there's a very definite line that your eyes perceive, okay, between the grass and the asphalt in this white line to the yellow line to this other yellow line and the asphalt in the grass again. Okay, so that is, canny is meant to help with OpenCV do the detection of the edges. Okay, and if we didn't put the ROI, that box around this center point, you'd start to see that there's a edge that's made around the trees, okay, and then the mountain range in the background. So your horizon line where the mountain meets the sky, and right here at the very end of the road. These are all transitional colors that go from one very strong color to another color. Okay, so that's canny edge detection, and that's why we're using it. Okay, it's an algorithm inside of OpenCV that helps us pick out those colors. So the next step we need to do is take our original image values that we have, and we actually have to convert them to this HSV. Okay, and OpenCV has it's CVT, so it's convert color. Okay, and we're gonna convert the colors inside our region of interest. Okay, and take that and convert it to an HSV. Okay, then we'll do some other things. So this is a function call from the library, and this is going to be ROI, and we're going to call, remember that we had our HSV image. Okay, and we made that, get that thing to go away. Let me complete that, and then we'll go back to where that HSV image is. So this will be color, and what I'm looking for is color RGB to HSV. So what that is color red, green, blue, OR underscore, and it is RGB, okay, to HSV is what I'm looking for. And you can see there's these other ones, right? There's RGB to gray, okay, to HLS full, HSV. So we want color red, green, blue to HSV. So we're going to convert our image to an HSV. Okay. Now this HSV image was this mat that we had created up top. Okay. And then even before then, when we were doing the windows, at some point we'll be able to actually look at that HSV image in its own separate window. Okay, so it's important that we do that step right now. And again, that's one of those things, there's really no point in explaining it. Okay, so I've got another thing I have to do, and it's called in range. Okay, in range, and that's another function call with a whole long list of parameters. Okay, and we're going to do ROI, and this is going to be scalar. Okay, so this is this scalar is a function call, and it's going to be we're just going to put values in it, 3 values. 179, and finally 0. Okay, we're going to put in a comma and do more scalar. Okay, so what you're seeing is your maximums and your minimums, okay, of the HSV values. Okay, so if I do scalar, scalar again. Okay, so I finished off that second scalar. Okay, so it was 87, 0, and 77. And then I have to put in threshold. Threshold is that other mat that we had up here, okay, with our mats. And of course, the first time around I spelled it wrong, so it wasn't working. So I had to go up there, copy that, and paste that in there, okay, once I fixed the spelling. Okay, so now we're going to do this step 5, okay, and we're going to use a vector. And within the vector, okay, we have these huff lines. That is an entire lesson. Okay, so I really wish I could get in there and show you that, but it's an entire lesson all on its own, okay? So we're gonna do this huff transform, and I'm gonna put the note in there in case you're familiar with a huff transform, to detect lines in our image. Okay, so this is where I've got to get in and actually use the code to do the line detection. So I'm going to do this vector. Okay, so it'll be a vector, and it'll be defined as vec4i. Okay, and it's, sorry, not round brackets. I should have known better. It's actually angles for a vector, right? And I didn't spell it right. So it's a vector, and it's going to be vec, and let's go down, vec4i. Oh, I passed it right there. Okay, in lines. Okay. Now I need to do a double. RHO, don't worry, just go with it. 1, then double, a double, and this one's going to be theta. This all has to do with printing the lines to the road. Okay, so this will be CV underscore PI, okay, and divided by 180. Okay, so now we're getting into the geometry of the lines so that we can print the lines to the screen inside of our point of interest. Okay, so now int threshold 50. I'm going to set that to 50. I've played around before with 43, but for now I'm just going to stick with 50, and I'm going to go double. So this is going to be min line. Okay, so this is my maximum line gap. So if you think about the yellow lines on the down the center of the lane, that's the gap between the lines. Okay, and I'm going to set that to 300. Okay, and now we're going to get to our huff lines P. Okay, that's what I'm looking for, huff lines P, and it's a CV function call. And this one is going to be everything that we just created just previous to this. Okay, so this is going to be DST, comma, lines. Okay, there's our vector. What else do I want to put in here? So you can see it with the IntelliSense as I'm going down, Visual Studio is telling me what I need left. So now I've got RHO, theta, threshold, all the parameter list is being highlighted that I need to put in here. Okay, so this will be like it says RHO, and then after RHO it's theta. Okay, and then it is threshold. I'm just looking for it. Threshold. What's next in there? min line length. So mine is min line length and max line gap. Okay, so that's the parameter list for the huff lines. Okay, so what that should do now is be the first part of defining, that's the geometry that's going to define where our lines are supposed to go. So here now we have to draw the actual lines on the screen over the road. Okay, and what we're going to do there is we're going to need an int line thick. Line thickness, I'm going to set that to 10 for now. Line type, so int line, line type is going to be a, there's a whole bunch there, but we're going to use line. You can see here it's got line 4, line 8, line AA, and there's also one called a fill, but for now we're just going to use line 4. Okay, and then what's next from that? Do I want to do the, okay, I could have put this like tips on an arrow pointing down the road and stuff, but I'm not going to do that. Next I need to cycle through that, and I'm going to do a for loop. Okay, and within the for loop, we'll see, see how that goes. Man, my typing is absolutely atrocious when I try to record these videos. So it's going to be size underscore t. That's what I'm looking for. Yep, size t. Okay, and that is going to be set to, this is just a regular for loop. Okay, so I will be less than the lines vector. Lines, sorry, with an ES, because it's the vector that I'm trying to cycle through. Dot the size of the vector. Sorry, I was missing the I equals. Okay, so it's size t is the data type, I equals 0. Okay, I, and then the size of the vector, and then just I++, like any old for loop. So we're going to do a vec for I. Okay, and we'll just call this L equals lines, and in there it'll be I. Okay. And the next thing is we got to actually give color to the lines. So this is a scalar, we'll call it green color. Okay, and then we'll define the color. So what this is this is actually BGR. Okay, so that's blue, green, and red. And actually I'll set that to 250, not 255. Sorry. So that's just going to give us the color of the line that's painting over top of our lines on our road. And then line is going to be, it's going to be a function call. This will be a kind of a long line, but we'll do ROI, comma, and it's going to be point. Okay, so we're going to have a couple of points here. Okay, there'll be 4 points. So just watch what I do in terms of the actual code. Okay, and this is a method call, or function call, sorry. C++, I prefer to say functions. Okay, and that's going to be 0. And then we've got a few of these, so I'm just going to type it in there. So this is the line. Okay, so it's inside the region of interest, and we've got 4 basic coordinates, so a start and a finish point for the green line. Okay, so point 1, and then we have the other point. Okay, so this is the way they're defined. We've got point 0 and then point 1, and with the other line it's 0.2, and 0.3. Okay, and then we're just using this green color that we defined earlier. Okay, right here on line 140, and then line thickness, and then the line type. Okay, so that's all we're doing to define how that line looks. Okay, so the next thing we got to do, and this is kind of the neat part, is we can go outside of that for loop. And believe it or not, we're actually almost done. Now, the way we want to actually display this to the screen, we've got to do a couple of things, okay? And I'm going to open it up in a couple of different ways, or a couple of different views, okay? And as I do that, I'm just going to comment out different views that I want to see of this. You'll see what I mean in a minute when we do it. So in order to finally see this, we actually have to call this function called IamShow. Okay, and believe it or not, OpenCV does exist in Python. A lot of people do this in Python. I've done it both I've done this lane finding in C++. I've also done it in Python as part of the Udacity self-driving car course. Me personally, I prefer it in C++, but Python's actually pretty nice to do it too. But these function calls like IamShow are pretty typical. They're all part of the OpenCV library, okay? So what I'm going to do is call the window, which one do I want? Probably window name is probably the first one, okay? And let me go to the very top because I forgot what I called all my windows. And just as a review, like all of these are the windows that I'm going to open up now. Okay, so I've got my window name was the original image. My window name 1 is going to show this same image, but more as a in an HSV. Okay, and I don't think I'm going to do the threshold image. And then maybe fine tuning. That'll be a separate window that opens up just so that I can. That's a separate thing. That window opens up on the side with all the sliders. So when I go down to here, I know my window name actually is going to open up my this will be cap image, okay? And before I do the other ones, what I want to do is just I need to write one little if statement so that I can actually escape this, right? I need to be able to get out of the program once the video is running. So this is just going to be if, okay. So that's just going to be if wait key is 20 frames. Okay, and you can kind of speed this up as well, is 27. And I believe 27 actually is the ASCII version of your escape key. Okay, so I'll do cout ESC for escape. Okay, and then finally break. Okay, and I'll put that in there. Okay, now I actually think we're almost done this, but let's do a build and then run this. Okay, so build the solution, see if there are any errors. So far I don't see any errors, but a whole ton of warnings, and that's okay. An error is not the same as a warning. So it's still building. So I'm gonna pause it, and then when it's done, we'll try to run this. Okay, so I did a Control F5, and it looks like it's actually running, which is not that bad for a first go around. And you'll notice a few things that's happening here. Okay, as the image is actually moving, you're seeing these stray lines all over the place, right? And that's because the conditions are actually changing inside the video. Remember, this is processing video that falls inside the ROI. And you notice right there, it just picked up the sign for the 35 miles an hour. The reason it's doing that is because based on what it's seeing and how it's interpreting the color on the image, it sees something that falls within those parameters. Okay, so for a first go around, this isn't bad. This is by no means something that you should be trying to use in your own automobile. not at all, not by far, but it's a good start. It's a good introduction, I think, to OpenCV. And I want to show you one other thing, okay? And there is one thing I do want to do is I'm just going to do a return 0 here. I just think it's a little bit better to do that. Okay, so what I'd like to do is actually go in and try looking at some of those other names. Okay, so if I put, I don't know what ROI was, I forget again, I think at the very top. I don't have the other one, I've got for the HSV. Okay, so what I'm going to do is actually call not ROI, it should be HSV image right here. So I'm gonna show the HSV image. Now, if I were to leave this the way it is, I'd have too many boxes up on the window right now. Okay, so I don't want to have those on there. So I'm gonna comment out the original image. Okay, so then I'm gonna start this without debugging. Okay, so what's important about this image here is this is all in my HSV values, okay? And you'll notice that the red line on the edges of the road kind of coincide with in the other video processing that we did, where the green lines were painting very consistently, okay, because they're represented as two lines here. But in the middle where I had the dash line, you notice in the video it was pretty sporadic. Anyway, we're using this HSV to further define much more rigid looking lines. Okay, that's how we're processing the image. Another way we could have done this was through grayscale and some other processes, but I wanted to do this just in HSV. I didn't convert it to grayscale or any other thing. But you notice also that all you're seeing in this particular image is the area that we defined by our ROI, our region of interest. That's all you're seeing in this video, okay? So let's have another look at something else. So one of the things I did here is I actually, let me move everything out of the way. What I did is I called this window name 2. I actually called the ROI on it. Okay, and that's what I produced. It's the original video, but now I'm just grabbing the ROI, okay, and nothing else. Okay, now I want to show you one more thing, but it's going to take me a minute to set it up. I'm going to include a different video into my project, and then I got to rotate it, but I'm not going to give you guys that. I just want to kind of prove a point here, okay? So this is a video that I actually shot from my dashboard a couple of winters ago. And I'm going to really quickly show it to you. And I'm going to open with Media Player. Okay, and I'm hoping I'm not swearing in it. Okay, look at the sun in my eye and look at the speed I'm going. Horrible. But look at the lanes. Okay, and also look at the snowdrift going over top. And look at the fact that the it's like sheets of snow that were going over top of the road. Okay, and it completely obscures everything. Okay, so computer vision is not augmented reality. Okay, so it's important to understand that a computer can only act on what it can physically see properly. Okay, so seeing all those clouds of snow or sheets of dusty snow go across and drift over the road, it completely obscures the boundary of the road. Okay, so I'm actually going to put that in there, and I'm going to call mine. One thing I have to do when I try to run it in here is I've got to rotate it. Okay, so I've put a line of code in here. Just looking for where I just put it. Yeah, so in order for me to run that video, I actually have to rotate it clockwise 90 degrees. So I can use this rotation function. So I have to actually change the video name, okay, because on line 82 I'm calling it roadlane.mp4, but I've got to change this to tomvideo.mp4, and I've actually put it in the project file already. So what I'm going to do is I'll save that, and then I'm going to run it, and I'm going to show you the limitations of what computer vision has to deal with. So as you saw in the original video, I've got the sun shining straight into my camera, okay? Which we're dealing with the manipulation of pixels, mathematical calculations that manipulate the weighted value of pixels on a screen. Okay, so when I've got a bright light shining into the camera, I'm actually manipulating the weight factoring of all the pixels of images that the computer has to process. Okay, so that has a huge impact on what the colors actually look like. So when we put in those HSV colors as sort of threshold values, they get obscured by environmental conditions. Okay, so what if this was nighttime? Okay, do my headlights on my car at night adjust those values? Now, before I run that, I'm going to have to update this and make sure it's on. And if not, I would have ended up getting the ROI of that video. Okay, so I'll do a start without debugging. Okay, look at this mess. Okay, look what it's trying to do. One of the issues I've got here is that my region of interest is inside my car. Okay, so that's clearly a problem for what I'm trying to do, and it's not detecting anything on the road. So the last thing I'm going to do is go out, move up my region of interest, and then see how the camera reacts. So as you can see, the region of interest is kind of centered on the screen here, but as the steering wheel in my car moves down, just look at the condition of what's happening inside that zone of interest. Okay, even if I were to try to manipulate the parameters, it's still quite ugly. So I'm trying to fine-tune this. I still can't get a good reading. There's just too much going on, too much confusion for the actual camera itself. Okay, look, it's not picking anything up there now at this point because it has no difference between the edges of the road that it can see because of the snow drifts. Okay, so we actually covered a lot of stuff in here, and I gave you a lot of unknown information in here, but I hope you kind of appreciated the what's out there, what's available to you in terms of doing computer vision. I really I enjoy it quite a bit. If you think about Tesla vehicles, they employ computer vision over using LiDAR, and some of their self-driving or autonomous vehicles use a lot of LiDAR and vision. There's also computer vision out in the space industry for satellites. There's computer vision that I've heard of with inside the locomotive industry or the train industry. Thales in Toronto, they're working on a big computer vision or autonomous train system, and they're employing LiDAR and computer vision. And everybody right now the trend is towards fully autonomous vehicles, and the majority of people are doing it with computer vision and LiDAR. Okay, so it just depends on you know, what technology you want to employ for this. So anyway, I just wanted to give a really brief introduction to computer vision in our final C++ video. And also, I guess I'll give a shout out to the Udacity self-driving car engineer course. It's a nano degree. It's very well done. Really enjoyed working on that one. And anyway, enjoy your time with this video, and good luck, and we'll talk to you soon. Thanks. Bye.